previous video, we looked at ways in which we can estimate the time and effort required to execute a project. So having these estimations in place, another important part of project management is to create a schedule for the project. So why is this creating the schedule important? The schedule can help the project manager monitor the timely completion of each task. And let's say if we are falling behind, we can also take corrective action. And this enables the entire team to move forward. So now let's reflect on this question of how do you actually go about creating a schedule, right? So what are the main activities involved in project scheduling? Can you think of some of these activities? You can pause the video and think about some activities before proceeding. Okay, so let's look at some of these activities, right? So one is we have to identify all the major activities which need to be carried out to complete this software project. And once we have done that, we have to break down each of these activities into smaller tasks. And some of these tasks may be dependent on each another, right? So we have to determine the dependencies among these different tasks. So for example, task B can start only after task A has been completed. Or let's say task B, C, D can happen in parallel. So such dependencies have to be determined. And then we have to also estimate the time duration for each of these tasks. And having this dependencies and time duration, now we have to represent this information so that all members in the team will be aware of these dependencies and time durations. And we'll be looking at some representations in this video. Then we go more concrete and start, we think about the start dates, the end dates for each of these tasks. And then what we do is we determine the critical path. So a critical path is a chain of tasks that determine the duration of the project. So we'll be looking at what a critical path is. And finally, we allocate resources, people or equipment or other things to these particular tasks. So now let's look at how we can identify and break down each activity into tasks. So one way to do it is to create what is known as a work breakdown structure or a WS. What it does, it breaks down the project activities into a set of tasks. And usually this is done by creating a tree-like structure. So the root will have the project name and each node is broken down into smaller activities, which are the children of the node. And then finally you come down to the leaf, right? And each leaf, it represents a task which can be allocated to a developer and which can be scheduled. And each task takes roughly 2 weeks to develop of development time. So let's look at a work breakdown structure for the Amazon seller portal, right? So this is the name of the project, which is the root. And then you have different nodes for, let's say, requirement gathering, for design, for development. And each of the leaf, as we saw earlier, it represents a task which can be allocated to a developer, right? And so, for example, some people will start working on the component diagram, others will start working on the database schema, right? And if we look at just the design and the development, right? So we can see that in the design, you create the component diagram, the database, the user interface, and the development involves all the modules or the requirements which we identified in previous videos. So now that we know what these different tasks are, now what we have to do is to create what is known as an activity network, which is nothing but, now that we know what are the different tasks, now we have to determine interdependencies. How are these different tasks dependent on each other? What are the estimated durations? How much time will it take? So all this can be done by creating what is known as an activity network. And the leaf nodes of the work breakdown structure, which we saw earlier, these becomes the nodes of the activity network. So let's look at one example, the same example. So this was the WBS or the work breakdown structure which we created. Now all of these leaf nodes become part of the activity network. So this is one example. And here you can see the arrows also determine the dependencies, right? So if you see the catalog management, which is part of the development, that can start only after you create the component diagram, the user interface, and the database schema, right? And so this graph-like structure, it determines the dependencies between different tasks. And it also tells us how much time or how many days are required for each task. So here you can see that catalog management has to be completed before inventory management can start, and order tracking can start only after inventory management is completed. But then we see that payment tracking, sales tracking, and customer feedback can happen in parallel. Right? So this is one example of an activity network. So another way to represent this information is to create what is known as a Gantt chart. So Gantt chart is a special type of bar chart, and you can see that each bar, it represents an activity or a task, and the length of each bar is proportional to the time duration planned for that activity. So in the case of the Amazon seller portal, we saw that the user interface and database schema can start together parallelly, right? User interface takes longer than the database schema. Here we see that these three modules, the catalog management, inventory management, and tracking, can happen only one after the other. But once order tracking is done, payment and sales and customer feedback all can happen in parallel. Right? So this representations provide the software manager as well as all the members of the team a visual representation of how the project is scheduled and what are the different tasks which need to be done. So to summarize, in this video, we looked at the main activities in scheduling. First, we need to identify all the major activities and break down these activities into tasks, which can be done by the work breakdown structure. And then we saw the activity network representation, which can help us determine the dependencies and the time durations. And representations like the Gantt chart can help us represent all of this information so that all members in the team will be aware of the schedule of the project. Now, the next important type of project estimation techniques is known as heuristic techniques. So in heuristic techniques, we provide estimations by doing some modeling using some suitable mathematical expressions. So a popular model which has been used to estimate effort is known as the constructive cost estimation model, or the COCOMO model. This model was proposed by Boehm in 1981. And the formula which is used to estimate effort is nothing but A multiplied by size raised to B, where size is the size of the project in kilo lines of code. And what is this A and B, right? So the values of A and B, it depends on the type of project or the type of software you're building. So Boehm, he classified projects as one organic. So an organic project involves building a very well understood application program, and the size of the team is also small, and most of them are experienced. Another type of project can be a semi-detached project, which has a mix of both experienced and inexperienced people, and they might have some limited experience building related systems. And the third type of project is an embedded project, where the project is strongly coupled with hardware, and the team size also might be large, and there might be many inexperienced people. So based on the type of project, there we assign different values for A and B. And what you have seen is that the effort, it not only depends on the size of the project, but also the type of project, the composition of the team is also an important factor in which the estimate depends on. So based on an empirical analysis of several projects, Boehm came up with these values for A and B for each of the types of projects. So you can see that the values of the constants of A and B, they are based on the type of project, right? And for organic projects, the values are the least. It's 2.4 and 1.05, and it is highest for embedded projects. And this makes sense because embedded projects, as we saw, it involves coupling with hardware, the team is large, there might be many inexperienced people, and because of this, the effort increases exponentially as the complexity of the project and the team increases. So based on these constants, the initial estimate or the nominal estimate is calculated in terms of the effort. Now let's take the example of the Amazon seller portal and try to come up with the initial estimated effort to build such a system. Right? The first thing which we need to identify is what type of system is this Amazon seller portal, right? So according to me, this is not a straightforward software system. There are several modules which have to interface with the main Amazon system, with the banks for payment, etc. So I would maybe classify it as a semi-detached system. In some cases, it can also be an embedded system, right? So now that we have identified what type of system it is, now let us try to, second thing to do is to estimate the number of lines of code. So recall that we had identified some requirements in the previous weeks. So we have adding, editing, deleting catalog, the inventory, tracking orders, payments, sales, customer feedback. So all of these things are there. And for each of these modules, I estimate the number of lines of code required. So how does one do it, right? So this itself is a very difficult task. And usually the project manager looks at data from previous projects to come up with these estimates. So for example, in a previous project, there would have been a module which captured customer feedback. And based on that, the software manager makes estimates for that module. So I add up all the lines of codes for all the module and I get the total of 4,000 lines of code, which is nothing but 4 kilo lines of code. So now let's look at the estimations which we have till now. We know that the system is semi-detached. We have the size in kilo lines of code. We plug these values in and we get the effort is roughly around 16 person months or 15.83 person months. So what does this mean? This is our initial estimate, right? So we require around 15.83 person months. That is around 16 people working full time can finish this project in 1 month. And based on this, we can estimate the cost, right? So let's say that the average salary of the 16 people is 75,000 per month. So then the total cost comes up to around 12 lakhs. So now, apart from the size of the code, we need to consider other factors also to estimate the effort required for a project, right? So let's reflect on this. So what are the other factors which have to be considered to estimate the effort required for a project? You can pause this video and think about some other factors before proceeding. Okay, so apart from the size of the project, so what other factors have to be considered? Let's look at that. So some of you might have said about the people working in the project, right? Some team members may be experienced, but not in the programming framework required for this project. Others may not have domain experience. So in this case, in the case of the Amazon seller portal, how an e-commerce application works, and hence some time will go in learning about the domain. So another factor can be the technical attributes or the finer details about the product. So is the database large? Is it complex? How complicated is the entire product? So is reliability an important part of the system? So these factors also have to be considered when we estimate the effort. And estimation also depends on the tools and practices which are used by the team, right? How if the practices and tools are not very effective, then maybe more effort is required for the project. So in the COCOMO model, after determining this initial estimate, some other factors are added in order to obtain the final estimate. And these factors are known as cost drivers, right? So this table shows 15 such cost drivers, and these attributes like the product, computer attributes, personal attributes, these are similar to what we discussed earlier, right? Like software reliability. So if the reliability required is very high, then we have a higher cost driver compared to when it is very low, right? So let's look at our example. So let's say we want to estimate the effort for the Amazon seller portal. Let's look at some of these attributes. So for example, we want the system to be highly reliable because orders and money are involved, right? So we will choose a cost driver which is very high for reliability. And maybe my database size, it is also quite large. So I will choose a cost driver which is high. Now, if we look at some personnel attributes, let's say my application experience of my team is low, right? So I will choose this as 1.13. which is higher than if it is very high. And let's say my team has good programming language experience, so I rate it as high, right? So the multiplying factor for all 15 cost drivers, they are multiplied to get the effort adjustment factor, right? So in this case, I'm just taking 4 drivers for simplicity. So let's recall that our initial estimate was 15.83 person month. Now I take these cost drivers, multiply all of them together, and this gives me the effort adjustment factor, which is 1.62. And now my final estimate is calculated by multiplying the initial estimate with this effort adjustment factor. And so I get an final estimate of 25.65 person months. So to summarize the COCOMO model, first we determine the type of product which has to be built. Then we estimate the number of lines of code for each module. And based on the formula, we get the initial estimate. And from this initial estimate, we calculate the effort adjustment factor by considering the 15 cost drivers. And then we multiply the initial estimate with these adjustment factors to get the overall estimate. So if you have noticed, one important thing to note is that the overall estimate, it depends on the estimation of the lines of code for each module, right? And so it is important to get as much detail about the software, and we should also be aware of our biases when estimating the size of various components. So to summarize, in this video, we looked at several estimation techniques, both empirical and heuristic. And another question now to ask is which technique to use, right, for a particular project. So what estimation techniques project managers use, it depends on various factors like the type of organization, the type of product which is being built, right? And it depends on the practices in your organization as well. So for example, the British Computer Society survey of more than 1,000 projects found that 92% of the project managers, they made their estimates using experience instead of formulas. So now that we have learned these estimation techniques, you will encounter these or maybe some variations of these as you start working in the software industry.